Hi, welcome to Vision Mathematics. My name is Thomas Wanda and I'm going to take you through the lesson on this video. On this video we are going to be looking at grade 12 trigonometry, compound angles. Welcome to lesson number 4. In this lesson we are going to be dealing with double angle formulae. First of all, what are double angles? A double angle is an angle expressed in the form 2a, where a is an angle. It is important to note that any angle can be expressed as a double angle. For example, 50 degrees can be expressed as 2 times 25 degrees, which is double 25. 45 degrees can be expressed as 2 times 22,5 degrees, which is double 22,5 degrees. X degrees can be expressed as 2 times x over 2. 4x can be expressed as 2 times 2x. This might appear trivial, but it is very, very important, as you are going to realize when we continue with the lessons. Double angle formula. Now in sine 2a, we can write 2a as a plus a, and then expanding this using the compound angle formula, we obtain sine a cos a plus cos a sine a. And rearranging this, remembering that multiplication is commutative, it does not matter in which order you multiply them. So swapping cos a with sine a, we obtain here sine a cos a plus sine a cos a. Now it's clear that these are like terms, they can be added. So the result is 2 sine a cos a, which is the double angle formula for cosine. In the same way, we can write 2a here as a plus a. So we have cos 2a equal to cos a plus a, and expanding that using the compound angle formula for cosine, we obtain cos a minus sine a, which is cos squared a minus sine squared a, which is one of the compound angle formula for cosine. And now we can replace sine squared a using this identity. Sine squared a equal to 1 minus cos squared a. So in place of sine squared a, we can insert 1 minus cos squared a, and removing the brackets, we obtain cos squared a minus 1 plus, observe the minus 1 multiplied by minus cos. 2 negatives here will make a positive. And then cos squared a and cos squared a are like terms. Adding them, we obtain cos 2a equal to 2 cos squared a minus 1, which is another double angle formula for cosine. But we have seen here that in the previous slides, cos 2a is equal to cos squared a minus sine squared a. So this time we want to get rid of cosine squared a. So we replace cos squared a with 1 minus sine squared a minus sine squared a. And these are like terms, and that simplifies finally to cos 2a equal to 1 minus 2 sine squared a. Let us now summarize the double angle formula. Sine 2a has only one variant. Sine 2a equal to 2 sine a cos a. Cosine is different. It has three variants. Cos 2a equal to cos squared a minus sine squared a. Cos 2a equal to 2 cos squared a minus 1. Cos 2a equal to 1 minus 2 sine squared a. Now this means that when dealing with cos 2a, you have three options to choose from. Now your choice will depend on what you want to achieve. If the result you want to achieve is a mixture of cosine and sine, it is advisable to try cos squared a minus sine squared a, because it is the one which has both cosine and sine. If the result you want to achieve, you want to produce, has only cosine, it is advisable to choose this one which has cosine. And if the result you want to produce only has sine, then you can try using 1 minus 2 sine squared a. Now observe that cos squared a minus sine squared a is a difference of two squares, and therefore it can be factorized. So sometimes you might have to factorize after substituting, depending on what you want to achieve. Let us have some examples on how to use double angle formula. Given that sine 23 degrees equal to t, express the following in terms of t. 1 cos 23 degrees, 2 cos 46 degrees, 3 sine 46 degrees. Let's look at the first one. There are two general approaches. One is to write t as t over 1 and use the definition sine 23 degrees equal to opposite over hypotenuse. Sketch a right angle triangle fitting t and 1 and use Pythagoras theorem to calculate the third side. Then after that you can write cos 23. But I prefer using the identity cos squared 23 plus sine squared 23 equal to 1, since we have the same angle here, 23 degrees, 23 degrees. So we have cos squared 23 degrees plus sine squared 23 degrees equal to 1. Then that allows us to substitute for sine 23. So we have cos squared 23 degrees plus t squared equal to 1. Then making cos squared 23 degrees the subject, we obtain cos squared 23 degrees equal to 1 minus t squared, and then taking the square root both sides and observing that 23 degrees is in the first quadrant. Therefore cos 23 will be positive, so we take only the positive square root. That gives us cos 23 equal to the square root of minus t squared. I begin here by writing down what we already have. We are given in the question that sine 23 degrees equal to t. We have also calculated cos 23 degrees in the first part, which gave us the square root of 1 minus t squared. Now question number 2 required us to calculate cos 46 degrees. Now we see we have a relationship between 23 and 46. 46 is 2 times 23 degrees, so this can be expressed as a double angle. 46 is equal to double 23. So we can write cos 46 equal to cos 2 times 23 degrees. Then using the double angle formula, we can either choose the one which expresses the double angle in terms of cosine or the one which expresses it in terms of sine. It is better here to use this one because this is given in the question. We are sure it is correct. This one is our own calculations. You might not be sure whether you have made a mistake or not. So choosing the formula, double angle formula, cos 2a equal to 1 minus 2 sine squared a. We make a substitution. That is equal to 1 minus 2 sine squared 23 degrees. Our a here is 23 degrees. Then that allows us to now substitute for sine squared 23. We can now insert t there. So that is equal to 1 minus 2t squared. Number 3, sine 46. Again, we observe that 46 is double 23. So that allows us to use the double angle formula. So sine 46 is equal to sine 2 times 23. Now we said sine 2a is only one version, so we just have to use that one. The double angle formula says sine 2a equal to 2 sine a cos a. Now we have sine a, we have cos a. Our a is 23 degrees here. So we can now make a substitution. First of all, using the formula to expand that, it is 2 sine 23 degrees cos 23 degrees, and then we make a substitution. That's 2, and sine 23 is t. Cos 23 is 1 minus the square root of 1 minus t squared, I mean. Now here are some practice questions. Observe that these don't depend on double angle formula only. It's mixed concept. Use everything you have learned from grade 11 up to grade 12. Given that cos 18 degrees equal to p, express the following in terms of p. 1 sine 18 degrees, 2 sine 72 degrees, 3 cos 36 degrees, 4 sine 36 degrees, 5 tan 36 degrees, 6 cos 48 degrees, and 7 cos 27 degrees. Here are the suggested answers for the practice questions. First of all, we were given cos 18 degrees equal to p. I put it here for reference sake. In the first question, we were required to calculate sine 18 degrees, and observing that the angle 18 degrees is the same as 18 degrees given here, so we can use the identity sine squared 18 degrees plus cos squared 18 degrees equal to 1. Then substituting for cos 18 degrees, we have sine squared 18 degrees plus p squared equal to 1. Making sine squared 18 degrees the subject, we obtain sine squared 18 degrees equal to 1 minus p squared, and taking the square roots of both sides, observing that this is in the first quadrant and therefore it is going to be a positive. We have sine 18 degrees equal to the square root of 1 minus p squared. Number 2, we were asked to calculate sine 72 degrees. We observe that we can express sine 72 degrees as the difference between a special angle and 18. It's 90 minus 18 degrees, where 90 degrees is a special angle. So we express that as sine 90 degrees minus 18 degrees, and applying reduction formula, which is from grade 11, that reduces to cos 18 degrees. Remember, the reduction formula which use 90 degrees will change the function. Sine 90 degrees minus 18 degrees is equal to cosine 18 degrees. And observing that we are given cosine 18 degrees, which is P. So we make the last substitution here. Sine 72 degrees is equal to P. Number 3, it was cos 36. You should be quick to see that 36 is 2 times 18. So you can use double angle formula there. So we express cos 36 degrees as cos 2 times 18 degrees. And then since we are given cos 18 degrees here, we choose the one which has cos 18. So that's equal to 2 cos squared 18 degrees minus 1. And substituting for cos 18, you obtain P squared minus 1. Question number 4. Sine 36 degrees. Again, we observe that 36 is double 18. So we use the double angle formula. Sine 36 degrees equal to 2 sine 18 degrees cos 18 degrees. And making the substitutions, that's 2 substituting for cos 18, which is P. Remember what I said about commutativity. In multiplication, it does not matter whether you interchange the position of the numbers, the answer is still the same. So we start here with the cos 18 value, which is P, and then sine 18, which we found to be the square root of 1 minus P squared. So sine 36 degrees is equal to 2P multiplied by the square root of 1 minus P squared. Number 5 is tan 36. We remember the definition or the identity. Tan 36 degrees equal to sine 36 over cos 36. And simply substituting, we found above here that sine 36 degrees is 2P multiplied by 1 minus P squared. Substitute there. Cos 36 in a previous part question, we found it to be 2P squared minus 1. Observe here that you cannot cancel these 2 with these 2, because in the denominator, 2P is not a factor of the denominator. We can only cancel factors. In the numerator, it's okay because 2P is a factor of the numerator. But in the denominator, 2P is not a factor. You can only cancel factors. Number 6, cos 48. We express 48 in terms of the given angle and a special angle, because we will be able to substitute for the trig ratio of a special angle, and we will be able to substitute for the trig ratio of 18 because we have them. So we split 48 into 30 plus 18 and then apply the compound angle formula. So cos 38 plus 18 equal to cos 30 degrees cos 18 degrees minus sine 30 degrees sine 18 degrees. Then we make the substitutions. Cos 30 degrees is root 3 over 2. Cos 18 was given to be P. Then that's minus sine 30 degrees is half. Sine 18 degrees we found to be the square root of 1 minus P squared. Equal to, that's making the simplifications, multiplying here, that's root 3 times P, which is root 3 times P over 2. That's minus. And multiplying by half is the same as dividing by 2. So that gives us square root of 1 minus P squared over 2 equal to, since this is a common denominator, we can simply subtract the numerators under that one denominator. So that will be 3P minus that, which is 3P minus the square root of 1 minus P squared all over 2. Number 7, cos 27 degrees. You study it and see how you can express it as a sum or a difference of a special angle and 18 degrees. We find out that 27 is 45 minus 18. So 45 is a special angle, so we will be able to substitute for the trigonometrical ratios of this special angle, and we can be able to substitute for the trig ratios of 18 degrees because we have them in terms of t. So here, applying now the compound angle formula, that will be cos 45 degrees cos 18 degrees plus sine 45 degrees sine 18 degrees. Making the substitution, cos 45 degrees is root 2 over 2, and cos 18 degrees, which is actually p, plus sine 45 degrees is root 2 over 2 sine 18 degrees. And finally substituting for these two, which we have already found in terms of p, and factoring out root 2, because root 2 over 2 is common. You have root 2 over 2 here and root 2 over 2 here. So factoring out, it is common. Here you remain with cos 18, which is p. Here you remain with sine 18, which is the square root of 1 minus p squared. We have now come to the end of the lesson. I hope you enjoyed it. Meet you in lesson number 5.